Hello, welcome back. So today we want to talk about solving quadratic type equations. First, we'll explain what those are, and then be able to determine whether or not an equation is a quadratic type equation. We'll understand that, and also then figure out how to solve one. So what do we mean by quadratic type equation? Well, quadratic type equation is any equation be written in the form to make it look like a quadratic equation. We know in general what one of those looks like. So it looks like this, where you have ax squared plus bx plus c equals 0, where a is not equal to 0, and a, b, c are a and b and c are constants. So if you can write it to make it look like this, and in this case also b and so the only term that has to be here is the squared term. The other terms are optional. If you can make it look like that, you can actually solve it using a quadratic equation methods, whether factoring, completing the square, or the quadratic formula. So as I show on the left, here's an example. So you have an equation that looks like this. Okay. Now, I'll say since we can write it like this, so x to the fourth can be written as x squared to the second power. Of course, x squared is the same as x squared to the first power. What that means is we can write it sort of in a quadratic form where it looks like this. Okay. You have something squared minus the same thing to some with some constant out front to the first power, then some constant. Make it look in quadratic form. What we can do then is we can actually solve this using quadratic equation methods, solve for x squared, and then we can actually figure out what x is. So our goal, our procedure to do this is going to be to solve a quadratic type equation. So write the equation in quadratic form. Once again, see if it can be. Not everything can be done this way, but if it can, kind of write it like this. Then we're going to use what's called a u substitution. So it can be written like this. We're going to, instead of having an x squared, we're going to replace that with a u. We'll talk about some substitutions for that. Then we're going to solve this quadratic equation for u. Then, once we get those values, one or two values, depending on the type of quadratic equation, we'll put it back in terms of the original variable, then solve for the original variable. Okay, let's explain how that works. And let's leave this here. Actually, let's just start over here with that example. I'm going to say directions will be to solve. So number one, let's just use that. So x to the fourth minus x squared minus 6 is equal to 0. Okay. First off, we recognize that we can write this as, we said, x to the fourth the same as x squared to the second power, x squared squared. We write this term as the same thing here in parentheses to the first power minus 6 is equal to 0. Okay. We can write it like this. Basically, I should say write as a quadratic equation. Once again, not everything can be done this way. If this had been like x squared, x to the fourth minus x cubed, we couldn't do it this way, but just works out this way. So basically, you're looking for something where this power is twice this power. Now, what we're going to do is use called a u substitution. I'm going to say let u is equal to x squared. Okay. Now, then I'm going to substitute into the equation, plug this in for replace x squared with u, and that's going to give me just u squared. Since x squared is u, that's going to be u squared minus u minus 6, 0. Okay, now we have a normal quadratic equation. We can solve for u. So what we'll do is then solve for this variable u. And once we get that, that's not going to be the end, but that's our first step. Now this one, you use the quadratic formula if you want. This one will actually factor. You can factor into u minus 3 and u plus 2. So if you know how to solve by factoring, set each one of these equal to 0. So we have u minus 3 is equal to 0. And I'm sorry, that should be a u, not an x. I'm used to writing x's. And then a u plus 2 is equal to 0. All right, so what we have here then is u is equal to 3 and u is equal to 2. -2. A little issue writing today. Okay. Now, once again, we're not quite done. This is in terms of u. So what we need to do now is substitute back. What I mean by that is put this back in terms of x. Okay, so we say u is x squared. And so what that means, then we have x squared is equal to 3, excuse me, and x squared is equal to -2. Okay, and now we can solve each one of these for x. Base this called the square root property. Essentially, it's like taking the square root of both sides. So x is equal to plus or minus the square root of 3. Do the same thing over here. X is equal to plus or minus the square root of -2. And then remember, if you have an imaginary number like this, negative under here, convert to I form. And so this is going to be x is equal to plus or minus 2 times, let me write this out here. This is the same as square root of 2. Actually, I don't need that on second thought. So this is square root of 2 times I. Okay. Now, also, one problem I should have mentioned before is since we had this x to the fourth, we typically expect to have 4 solutions, although some of those could sometimes be repeated. So that's what we see here. We have 4 solutions, 2 here, 2 real ones, and 2 imaginary ones. We have 4 solutions, plus or minus the square root of 3, and plus or minus 2 times the square root of I. Okay, so that's basically a quadratic type equation. Let's look at our next one. So number 2. Similar idea. So this time we're going to have x to the 6th plus 2x cubed minus 15 is 0. Okay, same thing. So in this case, we have here is once again, this power is twice that one. And so if I can write this as a quadratic equation. And so this is going to be x cubed to the second plus 2 times x cubed to the first minus 15 is equal to 0. So I'm able to write this as a quadratic equation. What's in parentheses has to be the same. Here to the second power, here to the first power. Now I'm using these u substitutions again. So I'm going to say let u equals x cubed. Okay, follows basically the same pattern I did on the first example. So now I'm going to substitute. And if I do that, then replace x cubed, where we've seen x cubed, replace it with u. So I'm going to have u squared plus 2u minus 15 is 0. Okay, now once again, so solve this and use either method to solve a quadratic equation you can. This will also factor, though, if you want to use the quadratic formula, it's perfectly good as well. This will factor into u plus 5, and I did it again. It should be a u, not an x, and x minus 3. And once again, stage one, these equal to 0 and solve. So u equal plus 5 is equal to 0. U minus 3 is 0. So for u, we have u is equal to -5 and u is equal to +3. And once again, what I'm going to do is substitute back. Put this back in terms of x. Okay, and so x for u is x cubed. That gives me then x cubed is equal to -5, and x cubed is equal to 3. Okay, now here we can think of like we did the square root, we think of taking the cube root of both sides. Okay, and what this will be then, this is be x is equal to the cube root of -5, and x is equal to the cube root of 3. Now in this case, since we have a cube root, it's not plus or minus, and also this will give us a real number. Okay, so both these are real numbers, and since it's a cube root, this is an odd root, we don't have plus or minus. Okay, now also one thing, the previous one is a 4th power equation, so we had 4 solutions. Here it's a 6th power, we kind of expect 6. this case, we only got 2. Well, actually, we have 2 real solutions. There actually would be other solutions, but actually have 4 imaginary ones, which we can't really get by doing this. But that's okay. We're just interested in the real ones, the real solutions here. Okay. Then let's do one last equation like this. Let's go ahead and just go down here. Number 3, let's say we have this. X minus 1 squared minus 3 times x minus 1 minus 40 is 0. Okay. So this one looks a little bit different, but you'll see it's the same thing. Notice we have this, and we have this same thing in parentheses. We have this squared. This is already in a quadratic form. We do it the same way. This is the first power, this is the second power. So once again, we're going to say let, or use substitution, let u be equal to x minus 1. Okay. Now, just like we did before, so wherever you've seen x minus 1, replace it with u, and then I'll say substitute. Substitute that in, and then it's going to give us u squared minus 3 times u minus 40 is 0. Okay. Once again, solve this. We can solve this once again by factoring. The quadratic formula is perfectly good. This will be u minus 8 and u plus 5. Okay. Same thing. So say each factor equal to 0. So u minus 8 is 0. U plus 5 is 0. So for u, we have u is equal to positive 8 and u is equal to negative 5. Then, once again, substitute back. So put it back in terms of the original variable x. So we said u is x minus 1. So now, where we see a u, replace with x minus 1. And so we have x minus 1 is equal to 8. And x minus 1 is equal to negative 5. And just solve each one of these. Okay. So add 1 to both sides, x is equal to 9. Over here, add 1 to both sides, x is equal to negative 4. And those are our solutions. Okay. So what we've seen today is how to solve what's called a quadratic type equation. So base has to be something that's very close to being a quadratic equation, something like this, where this term right here is essentially the square of that term, be written that way, okay, in terms of your variables. All right, you can write it in this quadratic form where this is, where this first term is this middle term, the variable of the middle term is that squared. If you can do it that way, do u substitution, write it as a regular quadratic equation, solve your regular quadratic equation in terms of u. Once you get your solutions, plug back in for x to get your original variable, and then just solve that. That's how we can solve a quadratic type equation. All right, once again, not everything can be put in this way. Instead of this been like x cubed or x to the fifth, something like that, if it hadn't been squared, this hasn't been twice, if this power wasn't twice that one, we couldn't do that. This is what it is, we can't. All right, so that's how you solve quadratic type equations. Thank you. Have a good day.